Hey, what's up, YouTube? We subnetting like a boss, part 2. I'm your host, Lightfoot. Thank you all for tuning in. Let's get right to it. Today, we're going to cover classless inter-domain routing, or CIDR, as you all may know. What is CIDR? It's a method ISPs use to categorize IP addresses in order to distribute them. Classless means it no longer uses its default address space. The slash notation tells you how many bits or ones are on. So 192.168.0.64/26 means there are 2 borrowed bits. So as you know, 192.168 is a class C address, so that would be 24 bits being on, or 255.255.255, or 24 ones and 8 zeros. Well, if you subnet a /24 to a /26, so now you have 26 bits being on and 6 bits being off, with the total being 32 bits. So as you can see, we have 24 ones for a standard class C, but then we have 2 more bits to make it 26. This is the purpose of learning decimal to binary like we learned in part 1. So with these 2 extra bits, you would have, if we were to break this down, 128, 64, 32, 16, 8, 4, 2, and 1. So if we take those extra bits here, put 1 there and 1 here, these will be zeros. These place markers in decimal and binary will be 0. So you have 2 ones on. So 128 plus 64 equals 192. So your new subnet mask will be 255.255.255.192. This is going to be your network mask here. Your network ID, your first network ID is going to be here. And this is going to be your new subnet mask, /24 being subnetted to a /26. Now, when we talk about subnet masks and its CIDR notation, there's an easy way to kind of understand what each value is. So as you can see, this is class A, B, and C. That's kind of how I broke it up. So if we go to, as we all know, here a /24 would be 255.255.255.0, or 24 ones and 8 zeros. So if you go down to the next one, you will have 25 ones and 7 zeros. So now your new subnet mask is going to be 255.255.255.128/25. Now keep going, and this is again decimal to binary is how we're getting this 4th octet. And now if you keep going all the way down, you'll get to 255. Now the same is with class B. Rather than dealing with the 4th octet in class B, you're dealing with the, let me go up here, 3rd octet. And it's the same. So if you look at the 3rd octet there and the 4th octet here, everything's pretty much the same. And now if you go to class A, everything works the same. So to understand CIDR, it's really not that difficult. A lot of times you look at the larger numbers and the different octets, and it can get overwhelming, but it's the same concept. So if you're dealing with a class A, honestly, you treat that 2nd octet the same way as if you're dealing with a class C and you're dealing with the 4th octet. Just kind of think of it that way, and I think it'll help you a lot. Now, another thing we need to know is powers of tools. You use powers of tools to determine how many hosts and how many networks you have. So subnets are determined by 2 to the power of S equals the number of subnets you have, And then hosts are determined by 2 to the power of h minus 2 for the number of hosts. Now, why minus 2? Because you subtract 2, one being for the network ID and one being for the broadcast address, to determine the actual number of hosts, usable hosts, you have in a subnet range. Remember that 2 to the power of 8 is 8 bits. All ones equals 256. So if you have a /24, you have 256 block size. You actually count 0 in your block size, because if you subnet down to like a /30, your first usable subnet is going to be 0 through 3, and then your next usable subnet will be 4 through 8, well 7, 4 through 7. You got 4 in each block size or whatever. Now, to determine block size, one thing I want to go on with the powers of tools. Now, we're going to use powers of tools again to determine the hosts and the networks, but to determine block size. So if you have a subnet like this, 255.255. Excuse my writing, 192. So if you take here, there's 192 here. Each block size, so in a class C, class B, whatever, what you want to do is take 256, since the whole block equals 256, and you want to take your subnet mask, which is going to be here, the 192, and subtract that from here, and this is going to determine your block size for each range of addresses. 6 minus 2 equals 4, and then 5, 15, 6. So your block size is going to be 64. So 0 through 63 will be your first block size, and then 64 through 128 or the 127 to be your next block size, and etc. But we'll get to that in the next slide. I just wanted to cover that while we're kind of in the power of the tools so you can understand what's going on. Now, CIDR answers these questions. What is the subnet mask, or how many bits are borrowed? How many subnets can be produced? What is the valid subnet IDs? What are the broadcasts for each subnet? In other words, what is the broadcast address for each subnet? How many hosts, usable hosts per subnet? And what is the block size? So we'll cover that in the next slide. Class C, we're going to do a Class C example. What we want to do is subnet network 192.168.0.0/24 so that it provides 2 subnets with the maximum number of hosts in each subnet. So we have 2 subnets, a subnet here and a subnet here. We need a range of IPs here. We need a range of IPs on the right and a range of IPs on the left. So as we know, a /24 is this. I'll do it up here. The /24 is going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now the question is, and the rest of these are going to be zeros. And I'll just put zeros. 1, 2, 3, 4, 5, 6, 7, 8. So that right now this is a /24. And this is one network with 254 hosts. Meaning, so if we were to do the power of tools, we have 8 zeros, the power of tools. So right here, we have 8 zeros going from right to left. So what we have is 2 to the 8 minus 2 equals 254. So we had 254 hosts, but we only have one network here. So there's only one network. We need 2 networks. So if we turn this to a 1, now we have 7 zeros. We have 7 zeros and 1 here. So if we turn this to a 1, let's turn this all the way to a 1, then we have 7 zeros here. And now this will be 2 to the first. So what we have, what did it say? We have here 2 to the first equals 2. We now have 2 networks. So we have 2 networks here. Powers of 2s. 2 to the first equals 2. And now, and let me get rid of this, we need to determine how many hosts we have in this network. So we have 2 to the 7th minus 2 equals, so if 2 to the 8th was 256, then 2 to the 7th would be half that. So that would be 128 minus 2, we have 126. So boom. So our new subnet mask will be what? What we're going to do, now that's decimal to binary. So we're going to do decimal to binary to find the subnet mask. We know how many networks we have. We know how many hosts we have per network, but now we need to find the subnet mask. So the subnet mask is going to be, we already know 255.255 because those are already ones. So we'll just leave those as that. Now we borrow 1 bit from here. We borrowed that 1 bit. So now the rest are zeros. And so, as we know, that's 128, 64, 32, 16, 8, 4, 2, and 1. So all these are zeros. We have 128. So our block size will be 256 minus 128 equals 128. So anyway, our first network will be, or our subnet mask will be this: 255.255.128. And then, so this will be our first network, or our default gateway on this side will be .1. Our default gateway on this side will be .129. And I'll show you now. So the subnet ID here is going to be .0 and .128. Our first user is going to be .1, .129. Our last user is going to be 126. And then our last user here is going to be 254. And then our address is going to be 127 for our broadcast, and then 255. So, in other words, our first network will be 192.168.0.0, and our second network will be I need to learn how to write with this thing. .168.0.128. So that's how you do that. That's how you subnet, or that's how you determine 2 subnets from a /24 using CIDR notation in the class C. Now we'll go ahead and go to the next one. Now for a class B, it's pretty much not going to be any different. The only thing, the main difference is that you will have larger hosts per block size. You will have more networks available, but the concepts is the same when you're dealing with, if you just focus on the 3rd octet or the octet that is asking you to focus on. Because if you look too deep into it, of course, oh man, there's 1,000-something IP addresses in this range, or there's 4,096 IP addresses in this range. Yeah, that may be true, but the block size may be 4. So in other words, the 3rd octet, you're going from 0 to 3, or yeah, or 0 to 3. You get what I'm saying? So you can't focus on how many IP addresses is in that range. You have to focus on the block size and what the question is actually asking, and then learn your powers of tools and learn that CIDR chart, you know, from a /8 all the way down to a /32, you'll really have a clear understanding of subnet masking. So right here, it wants to know what are the first 4 subnets if /23 mask is applied to 172.16.0.0/16. Now, what we know from this is what we know. That already that there's 8 bits on. 1, 2, 3, 4, boom. 1, 2, 3, 4, 1, 2, 3, 4, boom. Right there, that's 8, and the rest are zeros. Now this is saying a /23. So we want to add 1, 2, 3, 4, 5, 6, 7. 0, 0. And these will all be zeros. Now, here's our original subnet mask. We just went here and added 7 more. Now, if we go to the chart, there's a couple ways to do this. We could do decimal to binary to determine the subnet mask, or if we know a /23 on the chart, let's go back to the chart. So if we go back to the chart, a /23 is what? Right here. 7 ones or 23 ones, 23 bits on, and 9 bits off. Or 255.255.254.0. Now let's go back to that slide. So now if we had that CIDR chart memorized, we would know we had 255.255.254, or what we could do is decimal to binary. So we would add all the bits up, and since this is a 0, we know that's a 1, and subtract 1. All the bits equals 255. Minus 1 is 254 if you're doing decimal to binary. It's not that complicated. Once you figure it out, you got it. And so now we know 254 as our subnet mask, so we'll go down here and write our subnet mask 255.254.0. Now what's going to be our block size? 256 minus 254. And our block size will be 2. 2, what does that mean? Well, you're dealing with a 3rd octet. So what you want to do is you want to go by 2s. So your first subnet ID will be .0.0. Your second subnet ID will be .2.0. .4.0. .6.0. Or you write it like this: 172.16.0.0. 172.16.2.0. 117.16.4.0. And so that's what it's doing. So what is the first usable host? Well, we know the first usable host will be 1.0.1. Since the network ID is going to be 0.0. And then the second one for here is going to be 2.1. And then it's just going to keep doing the same thing. 4.1, 6.1. So your last usable will be, it's going to be 1.254. And this is going to be 3.254. 5.254. Then 7.254. And then your broadcast will just be one more than your last usable, 255. Now, I don't know if you ever try to write one of these pens, but it's not easy. I'm learning now. I'm going to get better. Working on it. All right, so we got that. So we completed everything it asked for. What are the first 4 subnets if a /23 mask is applied to 117.16.0.0/16. And we went through, we found the subnet mask of being 255.255.254.0. We found the first available, the first 4 subnet masks, the first host for each one of those subnet masks, the last host for each one of those subnet masks. In the broadcast, we know everything that it's asking for. It's fairly easy. This is a Class B. We treat a Class B just like a Class C, except we work with the 3rd octet rather than the 4th octet. It's not that hard. Once you learn, it will get even easier. Now, when we get into VLSM, it will get a little more difficult, a little more complicated, because you actually got to think as far as, okay, I'm subnetting over here, I'm subnetting over there. I can't have discontiguous networks, or I need my networks to be contiguous. You got to kind of keep all that in mind, your routing protocols and how you want to define and design your networks when you're using VLSM. But right now, when we're using CIDR, it's not that difficult. Now with Class A, again, you're dealing with the 2nd octet. It's not that complicated, people. Now here, it says, what are the first 4 subnets in the /20 mask if applied to 10.0.0.0, which we know is a /8 and is a Class A network. So if we were to go up here, now we have we know we got a /20. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8. So here's our network portion right here. Network portion is here. It's going to be 255.240.0. And we'll put that down here. .240.0. Now, if we take 240 or 256 and subtract 240, we have 16. So our block sizes are going to be what? 16 block sizes. So our first octet is going to be, and I'm just going to start from here, 0.0, and then 16.0, and then 32 and 32.0, and next is 48.0. And so the first usable is going to be 0.1, 16.1, 32.1, 48.1, and then the last is just going to be basically 2 less than the next network ID. Well, it's going to be, 2 less. So if 16.0 is the next, then this will be 15.254. Because this will be 15.255 as the broadcast. And so right here will be 31.254. And this will be 32 or 31, sorry. 31.255. And so on. I mean, I'll go ahead and do this just in case somebody wants to know. .254 and then 47.255. It's not that complicated. You just focus on the octet you're at and you keep it within that range. You don't worry about how many are in between, because it's going to tell you with the power of tools, it's going to tell you, how many hosts you have, how many networks you have. And so again, like I said, we have 496. 496 subnets and 496 hosts because of the power of twos. We had 2 to the power, or 2 to, actually we got 494. Sorry, you always have to subtract 2. Yeah, this pen is terrible. So 2 to the S equals 2 to the 12th, because that's how many bits we borrowed, is 496. And then 2 to the 12th here for the host minus 2 equals 494. And these are the hosts per block size. And these are the total subnets that you'll have. It's not that complicated. Once you practice, once you dive in, you'll have a better understanding. This completes part 2 of subnetting like a boss. Now, if you want to contact me, YouTube.com/Dewan Lightfoot, or hit me on Twitter at DLight330. Next week, next Tuesday, I will be coming with part 3 of subnetting like a boss. Please feel free to leave comments in the description below. Your feedback is truly needed, so I know that I'm giving you all valuable information. I thank you all for viewing. Peace.